I mentioned about cis and trans isomers at the very beginning of this chapter. Right, so let's review it real quick. All right, so cis and trans, we look at the same group on two different carbon on an alkene or on a ring. Right, that if they point to the opposite direction, that's a trans. Same direction, that's cis. If an alkene doesn't have the same group, you can look at hydrogen as well. And that's a trans isomer. By the way, so these are these stereo isomers are diastereomers, right? The reason is, first of all, they're not mirror images, right? But they are stereo isomers. They have the same molecular formula, same connectivity. All these carbon connect to the same way, but different arrangement, right? So they are type of stereo isomers. Cis and trans, we call cis and trans. And cis and trans is also considered diastereomers because they're not mirror images. Okay, so they are diastereomers. And down here, you can't really tell these two are non-isomeric because they got the same group on the same side on the same carbon. Right? So you can't really tell. Right? I'm able to determine cis or trans. Right? Now, certain type of alkene cannot just determine cis or trans because they have more than two substituent on it. This is tri-substitute alkene. You can't tell cis or trans. So we need to use another system to determine it. If you try to do cis or trans, for example, or like look at the ethyl group here, you don't say ethyl group on the other side, right? If you say look at the hydroxyl group here, you don't say hydroxyl group on the other side. You can't really tell, right? But we can kind of determine cis and trans, but we're gonna use E or Z system instead. Okay, and this is how E and Z system work. So E means, I don't know how to say. I think it's Greek, not it's kind of like German. I think it is from German. Professor told me it sounds like German. Susamen, I think that's German. Okay, but in Greek mean opposite. No. E mean I'm not gonna say in kicken. I don't know. In Greek this means opposite. E means opposite. Z means together at the same direction. All right, so similar to S and cis or trans. All right, in this case, this guy's E isomer. This is how we determine it. On this, we're gonna look at one carbon at a time. Okay, carbon on the left side, who has higher priority. The same way when you assign priority in R and S system. Chlorine versus carbon, totally chlorine. Okay, look at the other side. So we have carbon versus hydrogen. Carbon wins for sure. If the two priority group point to the opposite direction, that's an E isomer. So E opposite. Okay, E opposite. And if the two priority group point to the same direction, together, that's Z. Together, same direction. Okay. All right, let's try this together right here. So E or Z isomer, basically. All right, this guy right here, one side at a time. Carbon and carbon, the same thing, but this carbon connect to the oxygen. This carbon connect to the carbon. So we take the top one right there. All right. Down. So we take this guy. Now, this guy right here, we have carbon versus hydrogen. Totally carbon down there. Now this guy point up. This guy point down. Opposite direction. This is an E isomers. All right. If you do cis or trans, it is ethyl group, and ethyl group this is gonna be cis isomer, which is not E isomer. Totally different system there. So watch out there. Totally different thing. You cannot use cis or trans here. This is they are tri-substitute alkene. You cannot use cis or trans. Okay. All right. This guy right here, what we got on the left side, we have carbon versus hydrogen. Totally gold carbon. On the right side is carbon and carbon. Well, you have to look at what they bond to. The top one bond to carbon, hydrogen, hydrogen. Down here, carbon, hydrogen, hydrogen. Oh, they're tied. Go to the next atom along the chain. Top one right here, carbon, hydrogen, hydrogen. You can see now totally carbon, carbon, hydrogen. This guy's win, right? So we go down here. This is your priority group. Now the two high priority point to the same direction. This is a Z isomer. All right, this guy right here. See what we got on the left side. Start with the carbon right here. We have nitrogen versus carbon. Totally we go with nitrogen. All right. On the right side we have carbon and carbon. Don't look at chlorine. No, we can look at chlorine right there. One atom at a time. Carbon versus carbon. Same priority. Look at what it bond to. Carbon at the top, bond to carbon, hydrogen, hydrogen. This carbon right here, carbon, carbon, hydrogen. See that? So it's, priority group point to the same direction. That's a Z isomers. Here we go. All right. That's we have class activity number 5. Question 1, 2, 3, and 4. Answer right here. Answer, answer, and answer. All right. And that's it. Yay! Finished. I'll see you on chapter 6.